When a force is applied on a body, let's say this is a body. When a force is applied on a body, then what happens? Now, the question is what happens? All of we know that the body moves. But what kind of motion produces on this body? Now, I want to talk about this. Okay, when we apply a constant force, what it means? Constant force means if 1 Newton force is applied continuously, then that is called constant force, not like as a pulse. And we are applying force constantly, and this is called constant force. When a constant force acts on a body, then the body comes in motion, and what is observed? The motion, let's say this is the direction in which motion is observed. First, it was at rest, and that's why its velocity is 0 meter per second. But at the end of 1 second, suddenly it covers certain distance, and that's why if it covers 1 meter distance, then we can say that its velocity at the end of 1 second is how much? 1 meter per second. This is 0 second, this is 1 second. Now if the constant force, the same force, is acting on this body, then in next 1 second it won't cover only 1 meter distance, it will cover more than 1 or maybe 2 meter distance. And that's why at the end of second it will its velocity will be 2 meter per second, because in this particular 1 second it covered how much? 2 meter distance. In the same way, if the same force is constantly acting on the body, then in third second it will cover more distance. In third second, if it covers 3 meter distance in third second, then its velocity at the end of third second is 3 meter per second. In the same way, if force is acting constantly, then in another 1 second or fourth second, its velocity will be 4 meter per second, and another second its velocity will be 5 meter per second. This way the motion produces in this body. It means at first it was at rest, but when a constant force acts on it, then its velocity goes on increasing and increasing and increasing. And this type of motion, when the velocity goes on increasing and increasing, that is called acceleration. The body is accelerating. Now, how can we calculate this acceleration, and how can we define this acceleration? Actually, acceleration is rate of change of velocity. Rate of change of velocity. What it means? It means how much is the change of velocity in 1 unit time. That represents acceleration. Just for example, in this 1 second time, change of velocity is 1 meter per second. In second, the change of velocity is again 1 meter per second. In third second, 2 to 3, 1 meter per second is the change of velocity. That's why, how can we represent acceleration? Shortly this way: change of velocity divided by time taken. What it mean? Let's say a body moves from this position to this position. Now there is a lot of change. In every second there is change. Now, how much is the change of velocity from this point to this point? If this change of velocity is divided by the time taken to gain that much change, then we will get acceleration. If its initial velocity, the first velocity, is denoted by u, and final velocity is denoted by v, initial is 0, final is 5 meter per second, then change of velocity will be what? V minus u, final minus initial. And how long it takes to go from this point to this point? Let's say it is denoted by t. Then acceleration is denoted by small a. A equal to v minus u means change of velocity by time taken. This is the formula for acceleration. Now this is, in this case, this is how much? A equal to value of final velocity is 5 meter per second, initial velocity is 0 meter per second, and time taken to gain this much change is 1 second, 2, 3, 4, 5 second. 5 second. This is equal to 5 meter per second minus nothing, means 5 meter per second, and divided by 5 second. 5 cancel, 1, then therefore the acceleration will be what? 1 meter. This is in denominator, this is also in denominator, meter per second square. This is the unit for acceleration. What is it? Meter per second square. Now acceleration is rate of change of velocity, and its formula in words is like this, and its formula in symbol is this. We can calculate this way. This is all about the acceleration. I mean to say the basic concept of the acceleration. But we have to notice that we have to be very clear about this, that whenever force is applied on the body continuously, constantly, then only its velocity keeps on increasing or increasing, and then we'll have acceleration. But when force is ceased, let's say here 1 Newton force is continuously applied, but at the end of 5 seconds, if force is ceased, no more force is applied, then it keeps on moving with the same velocity, 5 meter per second, again 5 meter per second, again 5 meter per second, because force is not applied now. At this time, the body is not accelerating because there is no change of velocity. Until and unless there is change of velocity, will have acceleration. If there is no change of velocity, then no acceleration. Acceleration becomes 0. That's why force produces acceleration. We have to be clear about this also. Okay, this much for today.